Hello everyone, in this video we're going to demonstrate how to use the division and the modulus operator. So in particular we're going to output the current time in hours, minutes and seconds to the console. To do this we actually have to get what the time is. So we're going to ask the system class to tell us what the time is, and we're going to convert the number that it gives us into hours and minutes and seconds using the division and modulus operators. So let's get started. Over in Eclipse now, I've just created a project already. So let's just add a class to this. So new class. And this class is going to be called show current time. Oh, wrong field. There we go. And yes, Eclipse, make me a main method, please. So I'm just going to maximize this so we've got a bit more room to work with. And let's get started. So, how do we get the current time? Well, the system class can do this for us. It has a method called current time millis. So, let's get this, and it returns a long int. So, long total milliseconds equals system dot current time millis. And you can see the Java doc is telling us it's going to return the number of time in milliseconds. Exclamation mark. So, what number is this actually going to get us? The current time since when in milliseconds? Well, computers and a lot of programming languages all start counting time from the same point. And what this actually returns is, so we're going to obtain the total milliseconds since midnight, January 1, 1970. So the current time method will return the number of milliseconds that have occurred since midnight on January 1st, 1970. Now, why is this date so special? Well, pretty much all programming languages that have an option to get the current time use this date. It's known as the Unix epoch. And it's kind of important when it comes to time functions in computers. So it's a good idea to know what this is going to return, and the Java doc would have told us if we read down a little bit further. So, next thing we need to do is obtain, well, milliseconds, probably a bit too much precision for what we need. So we're going to convert this into the number of seconds. So again, long total seconds. Now, how do we convert from milliseconds to seconds? Well, we'll just divide by 1000. So, total milliseconds divide by 1000. So, this is the division operator. So, what's going to happen here? Well, remember that we're dealing with integer types. So, integer types don't store a decimal place. So, what we're going to get here is, imagine it returns a number like 1, 2, 3, 4, 5. Obviously, it's going to be a lot more than this. There's been way more milliseconds that have occurred since 1970, but this will do. And then we divide this by 1000. Now, the correct, the complete answer, if we don't care about precision, will be 1, 2, decimal place, 3, 4, 5. But remember that integer data types don't store a decimal place. What that means is that these numbers here disappear. Okay, the number isn't rounded down. So if we had a different number that was like 8, 8, 8, and we divide by 10, we end up with 88.8. This does not get rounded up to 89. That's wrong. And it's not really getting rounded down either. It just means that this decimal place, the numbers after the decimal place disappear. So the number's truncated. It just goes. So that's what happens when we do integer division. So we're going to lose whatever comes after the decimal place. And that's how we get the total number of seconds that have occurred since 1970. So the next thing, we should probably comment our code, is to convert this. So this is going to be a really big number. Now what we need to do is convert this and work out how many minutes and how many hours have occurred. So the first step is to work out what is the current second. So are we 37 seconds into the minute, or are we 14 seconds into the minute? And how we're going to do this is we're going to store another variable, current seconds, or second, equals. Now we're going to do a typecast to an int here. And we're going to do total seconds, %, the modulus operator, 60. Now, what does the modulus operator actually do? Well, imagine this. Imagine we've done total seconds divide by 60, and it doesn't go cleanly. We've got some remainder. And if we were this shows up as a decimal place when we're doing floating point divisions, but in integer division it just disappears. So what the modulus what this operator does is say, how many times does 60 go into total seconds, and then give me the remainder of that. So as an example, if we did 10 divided by 4, now we know that this will equal 2.5. But remember that if we're dealing with integers, then it just becomes 2. So what the modulus, what the %, the modulus operator will do, will say how many times does 4 go into 10, and then give us the remainder. So what we can do here is go 10 minus 4 equals 6, so that's 1 time, minus 4 again equals 2, so that's another time, and then 4 doesn't go into 2 anymore, so that's where we stop. So the remainder of 10 divided by 4 is 2, and that's what this function will give us. So 10 %4 will equal 2, because that's what the remainder is if we do a division. And that's what the modulus sign does. So what we're doing on this line of code is working out how many minutes fit into the total number of seconds, and then we're getting the remainder of that, which gives us our current second. So that's what this line of code does. So with that, that's probably a bit of a hint as to how we're going to work out the total number of minutes. Long total minutes. Oops. This is going to equal total seconds divided by 60. So how many minutes fit into total seconds? Now that we've done that, we need to know what the current minute in it is. And it's going to be a similar line of code to what the current second was. So long current minute equals, now typecast to an int, total minutes, %, 60. So what minute of the hour are we up to? Now we have to do a similar thing for hours now. So long total hours equals total minutes divided by 60. And remember that because these are integer types, we don't get 5.7. We just get, if that was going to be the answer, we'd just get 5. So finally, long current hour equals typecast to an int like before. But this time, because there are 24 hours in a day and not 60, we're going to do 24. So total hours, %, 24. All right. Oops, I forgot a semicolon. There we go. So that is all we need to do to calculate the current time in human readable form. So we've worked out the current hour, the current minute, and the current second. And let's print this out to the console. System.out.println the current time is, now we're going to do string concatenation here again, so plus current hour plus, now another string literal here, so we're going to have a colon to separate as the separator. Now I'm going to go down to a new line to separate things a bit, so plus current minute plus another colon plus current second plus G GMT. That's important. I forgot to mention that earlier. Current time in milliseconds returns the number of time in milliseconds since midnight, January 1, 1970, in Greenwich Mean Time. So if we, let's just put the main Eclipse UI back. If we save that, and let's run this. So project run as Java application. So it's saying the current time is almost 11 o'clock in the morning GMT. Now, if we open up my clock, it's currently 8:30 p.m. Now, I'm in Australia in time zone GMT plus 9.5. So 11 plus 9.5 is 8:30 in the evening. So that is the correct time. We've printed out the correct time in GMT. Now, if we wanted to print out relative to a time zone, we'd have to add some hours on or subtract some hours depending on the time zone. But for that, that's all we need to do for this video. We've worked out how we can use, well, let's summarize. So in this video, we used the method current time milliseconds, or millis, to return the number of milliseconds that have occurred since midnight, January 1, 1970. And this time is known as the Unix epoch. So we used integer division using the division operator, and remember that the value that gets returned is truncated, so there's no decimal places. It's not rounded, it's truncated. And then finally, we use the percent sign and that gives us the remainder of if a division operation occurred. So that's it for this video. Thanks a lot.